Good afternoon, ladies and gentlemen. The third talk of today is a talk entitled SoDeclarative, a declarative wrapper for OpenInventor, presented by Helmut, Sedding, and Michael Wagner.
Yeah, thanks. And I'm Michael Wagner, the CTO of IPO.Log GmbH. Welcome to our presentation. Let me introduce our company a little. We're a factory planning and consulting company. We do like if a big car manufacturer wants to plan a new car factory, we help them planning the production line setup and layout and all that kind of stuff. So we've got around 40 engineers, but not only construction specialists, but software developers as well, because we're developing our own software tools, which our engineers use for their daily planning work. So that's kind of a specialty about us. And we got projects all over the world. Yeah, let me present the IPO.Log software, which we're developing. It's an innovative solution for production and logistics planning, and it's all done with Qt in QML and Coin3D and OpenInventor 3D scene graph. So we want to visualize in 2D and 3D complex planning data, so factory layout and production lines and how workers assemble cars and where racks and materials are placed in the factory, and we can simulate how the workers are walking in the line, so in dynamically. And our own engineers use it for the daily work. So we get instant feedback if something doesn't work out, or how to make things better. So yeah, everything is, as I said, done in C++ and Qt for the date on Visual Studio in 2010. The 2D user interface is done with QML. And the 3D user interface is done with OpenInventor. So how many of you are actually doing QML development yet? Oh, so quite a few. That's cool. And how many of you have experience with 3D scene graph APIs like OpenInventor or OpenSceneGraph? Oh, so quite some. So which one? OpenInventor, that's cool. Everything? Okay. OpenSceneGraph. Yeah, that's nice as well. So yeah, let me just show our software a little, that you get the impression. Yesterday there was a talk of Helmut Sedding, my colleague, who gave you an explanation of the QML side of things. And today I'm gonna show you a little more about the 3D side of the application. So yeah, looks good. So let's just load a scenario. It's basically downloaded from a CAD system for the factory layout, and the other data comes from one big Excel file, which the engineers use for planning the production process. So what you see here is a 3D environment of the factory production line, right? We've got several workers and materials and racks and all that kind of stuff. And what you see around here is the 2D QML GUI. So you've got, for example, here a layout view of the 2D layout, right? So and what you see, if I select something in 2D, you see the corresponding 3D elements as being selected as well, right? So and if I like change a 2D element, the 3D element gets changed instantly as well. So we've got a very strong model presentation architecture. So we've got a big data model in C++. And data bindings with the QML GUI and the 3D environment as well. So what else can we do? We'll like show the products and get some simulation going. So what the software has done now, it has calculated all the worker paths and how the workers have to walk and where they do assemble every kind of things. I just speed that a little bit up. So you see them running and doing all kinds of stuff. So if I click on a worker. Yeah, so I can see I get some reporting information how far he's walking and how much of his time is really being productive and stuff like that. I've got a worker Gantt chart which shows me his production steps, what he's actually doing. And that's all done with QML, right? So and you've got also a planogram view, which shows which material is inside the material rack. So if I select something here, I've got an instant feedback in 3D. What's selected in material, and I can do like drag and drop and all that kind of stuff, which I'm used from normal applications, but everything, as I said, in QML. Yeah, so you've got an impression about the nature of our software, I hope now. It's just a tight integrated 2D, 3D user interface with data coupling in 3D and in 2D. So the graphics you see is based on OpenInventor. That's for those who don't know it. It's a 3D scene graph, which is used to describe the 3D content of the scene in a node-like structure. I just stopped that for a moment. OpenInventor is like really old. Actually, it was started by Silicon Graphics when they produced super graphics computers in the 90s. So but they said, well, OpenGL programming is like for a lot of our customers too complicated. Let's do some object-oriented way of defining graphic scenes, right? So they did that, and it's really a nice 3D toolkit for as a scene graph API. They GPL'd it they open sourced it as GPL in 2000. And sold the copyright to some other guys, which offer a closed source commercial version of it. And what we are using is the Coin 3D, which has right now this year been published as LGPL, so it's freely available and you can like just use it. A good thing is it has OpenGL, QGL widget support, and it's available cross-platform on Windows, Mac OS, and Linux. And actually, it's pretty well documented. there are two online books, or 2 books which you can download or just buy at Amazon as if you want to buy it. And really good documentation. So with Doxygen and all that what you need. And I said it's around since like the early 90s. I started using it at my time at Daimler Research at 1996. So and yeah, we've done lots of stuff with it, beginning from virtual reality, cave visualization for research, volume visualization in the medical field, commercially. It's like it's around for a really long time. Has been developed further, and yeah, we like to use it actually. So how does a scene graph work? It's you've got you define your scene with nodes, right? Which can be ordered in a hierarchy. So if I want to do for example, a cone, like you see here, a red cone, I do first well, let's do a material node. A transform if I want to move it around, and then the property, the cone itself is actually an object which is the node which is represented as a node in the scene graph, right? So and then if I want to render it, I just send a GL render action which traverses the scene graph, looks on all the nodes in the scene graph, and produces finally the rendered image, right? So I have parameters for the nodes. If for example here on the cone, I can define a bottom radius, which like changes the geometry of the items. So how would I do that in C++? So it's a C++ library, right? So just a short example, you would define such a scene which has in it a red cone with which is being transformed a little with these 3 statements. You derive a transform node object, and material node object, and a cone object, and you just throw this inside the scene graph, and that's it. So it gets evaluated, and the cone is rendered. Now we like this easy way of defining 3D scenes. So we thought, well, what we do all this QML stuff, and why don't we do it like for the 3D environment as well? So let's create a QML binding for all these OpenInventor nodes, that it can be used as in the same way as your QML definitions, right? So what we did, we wrote a generator which uses which just traverses the inventor nodes, and generates for each node type there a declarative wrapper class for it, right? So so finally, you can just define a SO scene 3D QML file which contains an inventor scene graph, which I will show you in a minute. We also wrote the SoDeclarative viewer, which just is actually a QGL widget which can render the 3D scene and the stuff defined in this 3D scene 3D QML. But let me just stop talking and let's try this for real. There we go. So just start up the declarative viewer, right? So that's the viewer, right? It's empty. And here I've got the SO scene 3D, which the viewer has loaded right now, right? Oh, okay, okay. How do I do that? Actually, I don't know. Zoom. Yeah. I just where was it? Is it like big enough now, or just a little bigger? Okay. Zoom. What about that? Okay, cool. So, what we've integrated in this declarative viewer, it just has a file system watcher and automatically reloads everything which has been changed. So, if let's just begin and do like this red cone example. So I write SO cone, right? Save it, and instantly I get the 3D cone, which I've just defined. So. But now it's a gray cone, right? So we have to use an SO material with a diffuse color 0 at red. And we got a red cone. So it's really straightforward. So everything is like written in line. So let's do an SO cube as well. So if I want a red cube, I just write SO cube, right? So the inventor defines several nodes for these instances, cubes, cones, but also you can also do triangle strip sets and everything you're used from OpenGL. So, but in a little more high level way of describing things. So yeah, that's actually the first example. A question so far? No? Okay. So let's get back to the presentation. There we go. So let me just go a little back to the technical side of things. How did we do that? We just derived an SoDeclarative node object from a Q object, right? Which wraps an inventor scene graph node, and which does also define for each field of this inventor node a Q property in the declarative wrapper node, right? So it also converts the inventor data types like SPVec3F, which is a vector, into the corresponding Q vector 3D in this case, but also for SP rotation to Q quaternion and all that kind of stuff. So yeah, the thing is, inside there is still the OpenInventor scene with OpenInventor nodes, but it's wrapped with the corresponding declarative nodes, which are accessible from QML. So yeah, now let's do another example. Let's build a table, right, with 3 parts: the base part, middle part, and a top part. Shouldn't be too difficult. So we're just using our viewer as well. Oh yeah, I forgot to mention this connections at the end is just a way of telling the viewer to view the whole scene if it's done loading, right? So you've got access to in QML to the viewer as well. So let's start off with a table base. So we've got an SO cube, width like 50, depth of 50, and a height of perps 5, right? What? Height, width, right? Thanks. Let's see. Oh yeah, it worked. Okay, good. So now let's take an SO cylinder with a height of perhaps 100 and a radius with, let's say, 5 as well for the middle part. So what you see here, it just starts everything in the origin, right? So we have to move the middle part a little to the height. So we do an SO transform with a translation and use a QtVector 3D 050, which is half the height, right? And we've moved it up, so it looks like a base of a table. So for the top, let's take another cylinder with a radius of 50 and a height of 5. Same issue. It's started in the middle. Oh, actually, we can copy that. Yeah, we got a table. So now that's pretty much OpenInventor structure, but we can also use like QML bindings for that. So let's make the height of the table a property, right? So property, right? Real height 100. And let's put that on height. So we need a height half. Let's see how it looks. Oh yeah. Height. Oh yeah, right. There we go. So if I then change the height property, the table behaves accordingly. Oh, we forgot. We have to actually adjust this this height as well. So and developing in that way is really quite nice, because you instantly get the feedback on your 3D scene just by saving it. Let's do something else. Let's choose for the tabletop between a cube and a cylinder, right? So OpenInventor has this nice SO switch, which switches between childs, right? Okay, 0 for here. Let's do an SO cube with 100, height 5, and a depth of 100. So nothing changed because I have to change the which child property. And we've got the, oh, let's make it a little, we've got a table, right? So if I take this and save it as an extra file, like an SoTable3D, for example, I've got a parameterized 3D component which I can integrate in another QML file as well. So that's really nice about it. I've prepared that actually. So let's yeah. Added some material as well, so there we go. Okay. So what's missing on the table? As we are developers, we need some coffee, right? So let's put an SO file and a coffee cup on the table. What is? I hope I remember the path. Coffee cup, complete.iv, perhaps. Oh, I guess it was just coffee. Was it? No. Oh yeah, the coffee cup is in the scene, but it's under the table. So what have we? We have to transfer it on the table, right? So let's do an SO transform. Translation. Qt vector 3D. Arrow. And since we've got the height property in the table, let's just put it that way. That should work out. No, it doesn't. Oh yeah, I forgot it. To close it. Yeah, a little more higher perhaps. There we go. We've got our coffee on the table. That's good. So Inventor can load like geometric files with 3ds format with OBJ and Inventor itself, which is the base for VRML. So if you guys know it, right? So, but what's better than one cup of coffee on the table? Let's do several, right? Are there questions so far? Pretty straightforward, huh? Time. All right. So, well, I forgot something actually. We you know from QML, you know the mouse areas, right? For interaction, and we transferred that into a 3D QML element, which is a pick area. In 3D, you don't have a mouse, but you have a 3D pointer which picks elements of the scene. So let's try to do something with our coffee cup. Let's say when we pick it, it should bounce in the air and just come down again, right? So let's so pick area. Let's first we need the bouncing as well. So let me just look at my little cheat sheet here. Yeah. Sequential animation. do a company. So let's put it in the air with a vector 3D animation, which is just a standard QML animation element. All right, and we need an transform to animate actually. So translation. Well, yeah, let's just name it and bounce. So we want to drive this translation. If I put an like an Q vector here, ten and 0. Oh. See, oh, right. Yeah, thanks, Helmut. And I'm, yeah. So, not yet. Yeah, it worked. So, see, we've got put the cup in the air, and now we want to animate that. Target is our bounce XF from 3D 000 to vector like 10, right? So, and one animation to come down as well with a little bouncy effect. Let's see, how did I do that? Right, easing type. Yeah. Arts bounce. Yeah, but I didn't do it in Qt Creator, so I wouldn't have had the help from it. So, and oh, we need a duration, right? 200 and a duration 200. So, do you see any mistakes yet? No? Okay, so let's come back to our pick area. The pick area is active on some target, which we have to specify. Well, let's do the whole. If we pick anything. So, and well, if we just got this on-clicked event, which gets called whenever the user clicks on a 3D item, right? So, company. And if we click, let's just start the animation. Okay, let's see. Oh, nothing happens. That's good. Oh, right. I have to good balance XF. Well, actually, it should work. Well, actually, it's let's just load the coffee cup 3D elements. So that's how it works, right? So, and Yeah, well, it's the separator actually. So let's do SO separator. That should work. Move it. Just move. Oh, let's do a coffee cup 3D. And do that. So coffee cup 3 is still not on the table. So it moves, right? So that's what we did. We did the same actually. So. Oh, I forgot the property, right. 15 minutes to go, so yeah. Okay. Yeah. So we have to define we have to set a property on which the animation runs, right? So okay. Better. So now, as I said, let's do some more coffee cups. We do in QML. You got the repeater element in our SoDeclarative. You've got an SO repeater. So let's say model like 3, and as a delegate, you just specify a 3D component as well. So separator and our coffee cup, right? And yeah, we have to translate it a little. Translation. Give it a vector. Let's do it like 20, 0, 0, right? And let's just rotate it accordingly to the index of the repeater. Rotation. So Qt 4.8 doesn't support creating quaternion rotations out of the box in QML, which has been integrated in Qt 5, I guess. So that's just so we supported that. Index is like that. That's 63. There we go. And we've got 3 cups, right? Which has the built-in mouse over animation. And so we're really really fast on creating things in 3D. But what we've also can do is integrate 2D content into 3D. So let's just how much time do I have left? 10 minutes. Oh, I gotta speed up a little. So you all know the SameGame, right? From QML examples. So what is it? The SameGame, I guess. let's see, what did I call it? SameGame, yeah. So we transferred that into 3D. So let's just put it on the table. There we go. Get rid of the coffee. Yeah. And move it a little more. There we go. So as you can see, it's like the SameGame surface, but with as you can see, with 3 elements, right? So we just exchanged that's just the same logic and JavaScript and all that, but we just exchanged the 2D QML elements with 3D elements, right? So here are the balls. And yeah, it's just straightforward actually. So let's look into the SameGame. Yes, so you see our 3D scene setup with an SO separator. That's all for the 3D scene. But here we've got also the SO canvas 3D, which creates a 2D canvas in the 3D environment, right? So you can just put a 2D window inside 3D and define content for it with QML. So as you're used to in 2D as well. So that opens the possibility to have really 2D combined 2D and 3D user interfaces, which I really like a lot. So yeah, that's about it from here. Let me show you some more advanced stuff with shaders. OpenInventor has also the support for shaders and data binding for it. So what we've done here is a little sample application which combines a shader with a data model in QML. For clarification, perhaps, what you see here. We've got a data model with Qt, which defines properties, scale and rotation. We've got an QML GUI element, just traditional, and we've got a 3D scene with a shader, which well, shows some height values and scales them with this scale property, right? And we've got a rotation element which rotates the landscape using this rotation property. So let's see how it's done. That's the scales a uniform shader, right? Element, and the rotation just rotates the inventor node. So yeah, actually, well, you can do all that shader stuff of the presentation before using this SoDeclarative approach as well, because yeah, it supports GLSL. So yeah, that's all I got. It's everything is LGPL open sourced at Bitbucket. So feel free to use it and give us feedback on if you like it, or if you can use it, or if you want to like share some other stuff with us. So questions? Everything set? Okay.
Cool. Lunch starts. Lunch is downstairs in Baku and Tashkent. Tashkent, yeah. And we start again at 1:30 then, if there's no questions.
Thank you.
We got one question. We got one question. Quick.
Just have one no, two questions, I think.
Yeah.
It's very similar to Qt3D, the QML interface. Did you
Yeah.
compare it? Yours look a little bit more advanced, I'd say.
Yeah, we looked at Qt3D, but well, yeah, I mean the development team has been fired as long as I know in Australia. So yeah, we thought about using it, but it wasn't there at that time. So for the syntax, it's kind of similar, yeah.
And the next question: will you have a problem with Qt5 and the declarative, which uses a scene graph?
We're looking into that because Qt5 does a scene graph as well, right? So we have to integrate a scene graph into a scene graph, which right now we're thinking of using a frame buffer object to do the inventor rendering and integrate that in as a item SG, as it's called, I guess. The Qt5 scene graph item. Proper, yeah. Here is a question.
Do you see any way to test this logic in QML? To write automatic tests for it?
Testing in what respect? Like if it looks right or?
No, if it behaves right.
Yeah, I mean you get the instant visual feedback, so or you don't, yeah. So if it doesn't behave, so
Okay, that's not automatic.
yeah. I mean you could log the transform values or something like that, and then compare it with what you expect. But for us, we've got our main work in the data model in C++, so we just use it for visualization, and we don't have much logic inside our components. Another question?
Yes.
Yeah, we got in.
When I looked at that, you have an LGBL license. Does that mean that? What does it mean?
It means you can use it for whatever you want, but if you modify the library itself, you have to share the code.
But are you allowed to include your GML, including the SO objects, in a resource file? Do you have to keep them external to not violate the license?
No. Just include them, I guess. It shouldn't be a problem. The QML file is your content. We just provide the generator and the structure around it. So you know. Okay. Thanks again. Next question.
It's only a short question. The canvas, I think, could you show it a little bit how it works with the button? And I think.
Well, if you got still the time, actually, so.
I don't know.
5 minutes. Yeah. Well. Yeah. Helmut is fond of the canvas, so we show it. Okay. Zip. Let's go back to our initial scene 3D. Right. let's get rid of all that. Let's do an SoCanvas 3D with a width of perhaps 400, width and a height of maybe 300, and units per pixel. That's how it scales in the virtual environment. And so let's do it like 0.1. Let's do rectangle. Oh, let's just do a calculator. I've got the QML calculator example from QML, right? So let's just embed that content inside. Oh, and we got the calculator, but let's get rid of the table. And we need a 500. Yeah, now we've got the space, right? And we can like interact with it just normally. The mouse events are transferred from 3D to 2D, and you get all the interactive elements as well. Yeah. So yeah, just go ahead and use it and would be nice to get some feedback.
Which viewer are you using for this?
It's the quarter widget from Coin3D.
SoQt or SoQt?
It's not an SoQt viewer, but the quarter. So it's based on the QGL widget.
Okay.
It's a library from the Coin3D project, but it's open source. You can use it.
I think that's about it now. Yeah, thank you very much, Michael.
Okay.
Thank you.
Thanks.